Hello everyone, this is Dr. A classes for BTech students. Today's lesson, titled River Erosion, is the fifth topic in engineering geology. The lesson discusses how flowing water wears away the land, transporting sediments and shaping the landscape over time. It is designed to provide BTech civil engineering students with essential geological knowledge. Learning objectives of the course is explaining the physical and hydrological processes that contribute to river erosion, understanding the relationship between erosion, sediment transport, and deposition in river systems, identifying the factors influencing river erosion, such as water velocity, sediment load, and the river gradient, describing the role of human activity such as deforestation, urbanization, and dam construction in aggravating or mitigating river erosion, evaluating the effectiveness of different erosion control measures in various contexts. Erosion by running water. Today we are focusing on a fundamental geological process that is river erosion. Rivers are not just channels for water. They are powerful forces that shape the very landscape we inhabit. We understand that river erosion is mechanical disintegration or chemical decomposition of rocks and their subsequent displacement. The destructive process because of the transporting agent. The most powerful agent of erosion besides wind, ice, and the fourth agent which helps erosion is gravity. River erosion is the process by which flowing water wears away the land. This is not just about the water itself. It involves the transportation of sediments, rock fragments, and minerals, and the constant reshaping of the terrain. Think of it as a continuous sculpting process. The journey begins high in the upper reaches of a river, often in mountains. Here, the water, driven by gravity, picks up rock fragments and minerals. These minerals are then carried down, sometimes for vast distances, eventually reaching the sea. Erosion is at its most intense in the upper course of a river. Several factors contribute to this: the steep gradient leading to fast flow, the often rocky terrain providing material for erosion, and the concentrated power of the water. This is where the river truly acts as a sculptor, carving valleys, creating waterfalls, and shaping the initial form of the landscape. Erosive power of running water. The picture depicts erosive power of a river, which is not a single force, but rather a combination of several interacting factors such as speed of flow, which is perhaps the most intuitive factor. Imagine throwing a pebble into a slowly moving stream versus a rushing river. The faster the water moves, the more energy it has and the more material it can dislodge and carry. Volume of water. A large volume of water simply means more force is being exerted. The sheer volume of water in a large river allows it to move much larger quantities of sediments and exert greater pressure. Gradient. This refers to the steepness of the river slope. A steeper gradient means the water flows faster due to gravity, increasing its erosive power. Load. This is the amount of sediments like sand, gravel, and even dislodged minerals that the river is carrying. Interestingly, the load itself contributes to erosion. Sediments act like sandpaper, grinding away the riverbed and banks, a process we call abrasion. Types of river erosion. Rivers are not just linear features on the landscape. Their erosive action is three-dimensional, working vertically, laterally, and headward to sculpt the terrain. Understanding these type of erosion helps us appreciate the diverse landforms we see along a river course. Vertical erosion occurs when a river cuts down into its bed, deepening the channel and creating V-shaped valleys, gorges, and canyons. It's common in the upper course of river where the gradient is steep and the river has high energy. Lateral erosion involves the wearing away of river banks leading to widening of the channel, forming meanders, floodplains, and oxbow lakes. It's predominant in the middle and lower course of rivers where the gradient is gentler and river meanders. Headward erosion occurring at the river source, the river extends its length upstream, potentially leading to river capture. This type of erosion can eventually lead to the river capturing the drainage of another river, a process known as river capture. Processes of river erosion. River erosion is a powerful force that shapes the Earth's surface, creating a variety of stunning landforms. Understanding the mechanism and factors influencing river erosion is crucial for managing water resources, predicting natural hazards, and appreciating the dynamic nature of our planet. River erosion occurs through several interrelated processes driven by the energy of flowing water, that is, hydraulic action, abrasion, attrition, solution or corrosion, transportation, and deposition. Hydraulic action. It is an erosive process that occurs when the motion of water against a rock surface produces mechanical weathering. The continuous impact of running water over the exposed rock masses breaks the rock masses. Broken rock debris are removed further downstream. Rocks containing sets of cracks, that is joints, are affected by the inherent energy of the flowing water, which often takes an important role in quarrying out the individual blocks. And once displaced from their original position, these tend to roll downstream along the river flow. Abrasion. Rock debris formed due to the hydraulic action of the river water move along with the running water in a river channel. The larger boulders and pebbles roll along the valley floor and move downstream, while the smaller fragments travel in saltation or suspension. The rolling boulders and pebbles collide against the valley floor during their travel, while the smaller fragments traveling in suspension impinge periodically upon the floor of the river valley. During abrasion at certain places, softer rock and pebbles of harder rock are caught up in eddies of water and have a swirling motion upon the river floor. As a result, the depression like potholes are formed. The sculpting power of rivers. Abrasion is essentially a sandpaper effect. The river carries a mix of sediment, sand, gravel, even larger rocks. As these materials are transported downstream, they constantly grind against the riverbed and the banks. Look closely at the rocks in these images. Abrasion is a continuous process in river system. It is a powerful force that contributes significantly to the shaping of river valleys, the creation of smooth riverbeds, and the overall evolution of the landscape. Both these images, though seemingly simple, reveal complex story of erosion and the relentless power of moving water and its load. Attrition. It is a process that shapes our coastline and geological landscapes. While erosion and weathering initiate the breakdown of rocks, attrition takes over, acting like a sculptor that refines and transforms these fragments into smooth, rounded forms we often see. It is the process of breaking down of transported rock fragments due to impact among themselves has been described as attrition. Attrition occurs when waves cause loose piece of rock debris, that is scree, to collide with each other, grinding and chipping each other progressively, becoming smaller, smoother, and rounder. Scree also collides with the base of the cliff face, chipping a small piece of rock from the cliff, or has an abrasion effect, that is corrosion, similar to sand papering. Solution or corrosion. It is a significant process in the shaping of landscape, particularly in areas with abundant limestone bedrock. It contributes to the formation of unique and often spectacular features found in many parts of the world. Corrosion or solution is a form of chemical weathering where flowing river water dissolves soluble minerals within rock. Rainwater absorbs carbon dioxide from the atmosphere, forming weak carbonic acid. This acidic water reacts with certain rocks, particularly limestone, calcium carbonate, dissolving them. These dissolved minerals are then carried away by the river. Solution can create a variety of landforms, including caves and caverns, potholes in riverbeds, swallow holes where rivers disappear underground, limestone pavements with deep fissures. Transportation. Material which has been added to the load of the river by erosion is transported in the following ways. Suspension. Sus- Suspension is the process where fine particles like silt and clay are kept afloat within the water column by the turbulence of the flow. These particles are so small and light that the upward current within the water can counteract the force of gravity, keeping them suspended. The muddier the water, the higher the suspended load. The more turbulent the river, the larger the particles it can carry in suspension. Larger particles, however, like sand and gravel, are too heavy to remain suspended. They are moved closer to the riverbed through two distinct processes, that is, traction and saltation. Traction involves the largest particle, like pebbles and cobbles, being dragged or rolled along the riverbed by force of the flowing water. Saltation, slightly smaller particles like sand and sand grains are lifted briefly into the flow and then bounce along the riverbed. They are too heavy for continuous suspension but light enough to be lifted and transported in short hops. Finally, we have solution. This is the least visible form of transport. Certain minerals in the rocks are dissolved by the water through chemical weathering. These dissolved materials are then carried downstream in solution. While invisible, these dissolved load contribute significantly to the overall amount of material transported by a river. Sediments transportation downstream. Rivers are not just conduit for water, they are also major transporters of materials. This material, the river load, consists of sediments ranging from tiny clay particles to large rocks, all product of erosion. Understanding how this load is moved is crucial to understanding river dynamics and the formation of landscape. The type of load a river carries and how it transports is depicted in the figure, which reflects the geology of the area, the river's flow regime, and the overall erosion process at work. Understanding these mechanisms is crucial for managing water resources, predicting river behavior, and appreciating the dynamic nature of our landscape. Deposition. It is the process by which transported materials such as sediments, rock fragments, etc., are laid down or dropped by a transporting agent such as river. Factors that affect deposition: particle size. Larger, heavier particles tend to settle out first as they require more energy to keep them in motion. Smaller particles can be carried further and require less energy to deposit. Particle shape. Streamlined, smooth particles are more easily transported and require lower energy to deposit compared to angular and rough particles. Particle density. Denser particles are heavier and require more energy to transport, leading them to deposit sooner than less dense particles of the same size. Velocity of flowing water. The faster the water flows, the more material it can carry. As the water slows down, its carrying capacity decreases, leading to deposition. Factors influencing river erosion. There are several natural and anthropogenic factors influencing the rate and extent of river erosion. Natural factors: velocity of water. Faster flowing water has greater erosive power. Sediments load. Rivers carrying more sediments can cause more abrasion. River gradient. Steeper gradients increase the energy available for erosion. Bank and bed materials. Soft, unconsolidated materials erode more easily than hard rocks such as granite. Climate. High rainfall and flooding events increase erosion rates. Human activities. Deforestation. Removal of vegetation reduces bank stability, increasing erosion. Urbanization. Increased surface runoff from impermeable surfaces accelerate erosion. Dam construction alters flow, leading to erosion downstream. Agriculture. Poor land management practices can aggravate erosion. Impacts of river erosion. River erosion has both positive and negative impacts on the environment and human societies. Positive impacts are landform creation. Erosion contributes to the formation of valleys, gorges, and floodplains. Nutrient distribution. Sediments transported by rivers enrich floodplains, supporting agriculture. Habitat formation. Erosion creates diverse habitats for aquatic and terrestrial species. The negative impacts are loss of land. Erosion can destroy agricultural land, settlements, and infrastructure. Displacement of communities. Severe erosion may force people to relocate. Water quality degradation. Increased sediment load can harm aquatic ecosystem. Economic cost. Erosion damages road, bridges, and other infrastructure requiring costly repairs. Formation of rivers. Rivers, the lifeline of our planet, don't just appear magically. They are sculpted over time through a continuous interplay of natural forces. Rivers originate from marshes, lakes, and melting glaciers. Gravity plays a major role in the direction of flow of the river. One of the sources of water that replenishes the river is the melting snow and the rainwater. When it rains heavily in the hills, the water trickles down the steep slopes. Initially, the water from the hills flows as surface runoff. Water flows after a certain distance in parallel rills. These parallel rills unite to form a stream. As the rills converge with the stream, a brook is formed. This brook flows through a valley. The brook becomes a river when the water level in the brook increases. Types of rivers. Rivers can be classified as youthful river. A youthful river typically found in upland areas with steep slopes. These rivers are characterized by a fast flowing current. The water is rushing, carving a deep V-shaped valley, actively eroding the land vertically. Features like waterfalls and rapids are typically found in this state. Tributaries, smaller rivers joining the main one, are relatively few at this point. A mature river, as the river moves into its mature stage, it starts to settle down a bit. The gradient becomes gentler and the flow slows down. The valley widens and we start to see the development of a floodplain, a flat area on either side of the river. A key feature of mature river is the formation of meanders, those beautiful bends you see in rivers. Lateral erosion or erosion sideways become more dominant now, widening the valley, more tributaries joining the river, increasing its overall size and complexities. Older river. In this, the gradient is very gentle and the flow is the slowest of all three stages. The valley is wide and flat with broad floodplain. Meanders become very pronounced and you might see oxbow lakes, these U-shaped lakes that were once part of river channel, deltas where the river deposits sediments as it enters a large body of water may also form. Deposition is the key process here. The river is more focused on carrying and depositing sediments than actively eroding. River deposits. River deposition is the last phase of geological work of a river. Among the different kinds of river deposits, a few are listed below. Alluvial cones and fans. These fan-shaped deposits of sediments form where river or stream flowing down a steep slope, like a mountain, abruptly enters a flatter area like a valley or plain. This sudden decrease in velocity causes the river to deposit its load of sediment. Placer deposits, these are accumulation of valuable minerals like gold, platinum and diamonds that have been concentrated by action of flowing water. Delta deposits, deltas form where a river enters a large body of water like an ocean, sea or lake and deposits its sediments load. The river's velocity decreases as it meets the larger body of water causing deposition. Natural levees, these are elevated ridges of sediment that form along the banks of a river during floods. River valley. A valley is a depression or lowland surrounded on sides by inclined hill slopes and mountains. Every river cuts its own valley by eroding the rock or the soil material from its path and transporting it down to sea. A very deep river valley may be called a canyon or gorge. River valley can be V-shaped or flat-flowed valleys. V-shaped valleys, it is a narrow valley with steeply sloped sides. Flat-flowed valley, such valleys are formed at mature stage of streams when V-shaped valley changes into a broad flat valley floor. At the end of the presentation, these are self-assessment questions. Go through each question carefully, answer these questions based on understanding of the topic, review any concept you are unsure about. The questions are: discuss the different types of erosion, hydraulic action, abrasion, attrition, solution, and how they contribute to shaping river valleys. Explain how factors like gradient, velocity, discharge, and the type of rock influence the rate of river erosion. how the rate of solution is influenced by factors like water flow, temperature, and the amount of dissolved carbon dioxide. Explain. Describe how human activities such as deforestation, urbanization, and dam construction can affect river erosion rates and patterns. Discuss stages of river development from the youthful stage in upland area to their mature and old stage in lowland regions. Thank you for joining this lesson on engineering geology today. Hope you found this presentation informative. Don't forget to like and subscribe the channel Dr. A Classes for more engaging lessons on core subjects of civil engineering.